We're going to do similar methods for our least common multiple. The LCM stands for our least common multiple. Multiples are larger. The multiples of 2, that's when we count by 2s. 2, 4, 6, 8, 10, they get larger. So for this one, our answer is always going to be larger than the given numbers. Even though it has the word least on there, multiple means that we're getting larger. So that's why my answer is always going to be larger. And this is the least, means it's the smallest whole number that is a multiple of the numbers given. Our methods are going to work very similar to what we had before. So I said those multiples, that's like the multiplication table. So we can come down here and look at these guys. That capital M just stands for multiples. Multiples keep going forever. They're an infinite set. Before we had a finite set. So the divisors are just set. They're finite. They don't keep going forever. Our multiples are. So you kind of have to do a little bit of like, prognosticating, just kind of a little bit of guessing on where to stop. So I'm going to do the multiples of 12. 12 times 1, 12 times 2, 12 times 3, 12 times 4. I know that I've got to get at least the multiples of 24, so I'm going to do another one. So 12 times 5. This isn't enough. I can come back and add some more. That's why I have the dot, dot, dot. I can always add more. Now I'm going to do the multiples of 18. 18 times 1, 18 times 2, 18 times 3, 18 times 4, and 18 times 5. Well, I can already see that I might need to go up further because I got all the way up to 90 when I did the multiples of 18, but we'll see. I might can go back. Maybe I won't. We'll check in just a second. The multiples of 24. 24 times 1, 24 times 2, 24 times 3. Now, I've got these 72s. If I come back up to this multiple of 12, this was 12 times 5. 12 times 6 is 72. So all three numbers, numbers I was given, 12, 18, 24, 72 is a multiple of all three of those. So, you might have to go back to that smaller one. I had to list out a lot more of them. That's because 12 is half the size of 24. So it didn't take as many to get to 24. So you just kind of have to go play around a little bit. But technically, each one of these sets is infinite. I could keep on going, but as soon as I hit the first number that appears in all three of them, that's what the LCM is. So this is the LCM of 12, 18, and 24. The answer is 72. I gave this one had 3 numbers. You can find the LCM of 2 numbers. I've got them listed down here, just like we did over there with the GCD. Technically, I can make a list that was 10 numbers long. You're not going to have to worry about that, but there's no set amount of given numbers. All right, let's try that prime factorization method. It's going to start the same way as before. We're going to list the prime factorization of each one of these really big numbers. So 2,520. We're going to make a factor tree. I saw it ended in 0. It's so big. So I did 10 times 252. Again, start your tree however you want to. We're going to get the same prime factorization at the end. 252 I divided by 2. I divided by 2 again. That was odd, so I divided by 3. So I got 2 cubed times 3 squared times 5 times 7. Same thing for 10,530. Again, I divided by 10 to get rid of that 0. Had an odd number, so I went on and divided by 3. Divided by 3 again. 3 again. And 3 again. And that gave me, let's see, a 2. 1, 2, 3, 4 times 3 to the 4th times 5 times 13. So I did the prime factorization. Now, what we're going to use is what changes. Remember, we want multiples, so we want large numbers. And each one of these prime factorizations, each one of the numbers in there is a factor of my answer. So I need to use each one of them. So this time I'm going to use all the bases because I need to make it as big as possible. And we're going to use the largest. So we want to use the largest number. Before, we were going with our smallest. So between 2 squared and 2 cubed, I went with 2 squared because I was getting the greatest common divisor. Divisor meant small. Now I'm going with my largest. So I'm going to always choose largest. So I've got 2 cubed is bigger than 2. 3/4 is bigger than that 3 squared. They both have the same 5, so it doesn't really matter where we choose the 5. They're both 5 to the first. And then I have to use every base. So I've got to use that 7 and 13 as well. To be a multiple, you have to include every single one of the factors. I typed all of those in at one time, one big, huge answer. Remember, my answer should be bigger than both of those. If you want to check yourself, you can take your answer here, 294,840 divided by 2,520. You should get a whole number. Take our answer, 294,840 divided by 10,530, and also get a whole number. All right, I'm going to ask you guys to pause the video. And for this one, see if you can work it all the way out. Make the factor tree and also see if you can find the least common multiple as well. All right, let's see how you did. If you haven't had a chance to do it again, pause the video and see if you can work this one all the way through, make the factor tree, and find the actual least common multiple. Here we go. Again, start it however you wanted to. You could have started with 10 and 14 and got the same answer. That's the really cool thing about factor trees. So my answer for my factor tree part is going to be 2 squared times 5 times 7. So that's my prime factorization for 140. Do the same thing for 320. Make my prime factorization. So many 2's. Let's see, 1, 2, 3, 4, 5, 6. So this gives me 2 to the 6 times 5. So my answer is I'm going to go with the largest exponent for each one of the bases. So 2 to the 6. 5's the same for both of them. And then I've got to include that 7 in there as well. Technically, the reason I include it is there's a 7 to the first, and this one would be a 7 to the 0. 7 to the 0, anything to the 0 powers 1, so it doesn't change my prime factorization, and 1 is bigger than 0. So that's technically why I do have to include it. But I'm just going to erase that because I know 7 wasn't part of the factor tree. Typing that in my calculator, I'm going to get an answer of 2,240.